In this video, we're going to focus on trig equations, and our goal is to solve for theta. So we're going to do two examples, and just notice that I do have out my notes page, as well as my unit circle for when I'm working on these problems. So our goal here is to get theta by itself, and let's focus on getting exact answers and then all possible answers. All right, so here we are in trig equations, and here is number one. Our goal is to get the theta by itself, and I notice that if I cover up sine and just focus on the theta, I'm noticing there's a plus 3, and the opposite of plus 3 is subtract 3. So I'm going to do subtract 3 from both sides. And 3 minus 3 is a 0. 2 minus 3 gives me -1 is equal to sine theta. Now, theta is not by itself. In order to remove that sign and put it to the other side, we're going to do the inverse of sine. So sine inverse, which is denoted with that -1 in the exponent, of -1 is equal to theta. I want to know where on the unit circle is sine -1. And just a general reminder, cosine and sine. So we're going to be looking for where that y value is -1. Coming up here, I'm looking for sine, my y value, to be -1, and it's right here at 3 pi over 2, which is also 270 degrees. So for theta, I can put 3 pi over 2 if I'm dealing with radians, and I can also say 270 degrees. Now, if they were asking for all possible answers, all possible, that means not just one rotation around the unit circle, but multiple rotations around the unit circle. So for dealing with radians, what I would do is add a rotation and then the number of times I rotate. If you're dealing with degrees, 360 degrees is a full rotation times the number of times we rotate around. So if it mentions all possible, make sure to add these two to the end of both of your exact answers. Now let's look at example 2. Again, let's just cover up that cosine, and notice I have two things being multiplied together, a -6 times that cosine theta. And over here I have 3√3. Now don't be scared when you see radicals in your equations, because if we look at that unit circle, notice, let me zoom out, that our √3s and √2s are on the unit circle. So having a √2 or √3 is very normal. So what I'm going to do is divide both sides by a -6, again, because they're being multiplied together. So we're going to divide by -6, divide by -6. This reduces to 1, giving me cosine theta. Do not reduce the radical. You cannot reduce the radical, but you can reduce the two whole numbers. So 3 and 6 can be reduced by 3. Reducing by 3 gives me a 1. Reducing by 3 gives me a 2. Notice I do have a negative in the value. I'm just going to put the negative in the front. That gives me √3 over 2. Our goal is to get theta by itself. So I'm going to put my theta here. Do the inverse of cosine, -√3 over 2. Where on the unit circle is cosine, -√3 over 2? Coming over here to my unit circle. Cosine is the x value, so x is going to be negative, so √3 over 2. That's at 5 pi over 6. And it's also at -√3 over 2, 7 pi over 6. If you want to know what those are in degrees, here's 180 minus 30 is 150 degrees. And then 180 plus 30 is 210 degrees. All right. So here are my my two possible in radian and my two possible answers in degrees. If they were to ask for all possible, you would add 2 pi times the number of rotations for all possible in radians. And if we're dealing with degrees, here is my all possible. A full rotation times the number of rotations. Be prepared for all possible as well as radians or degree answers.